Next, we have Sandeep from Polygon. I think he needs no introduction. So, Sandeep.
Hello, everyone. I was not told that I'm going to be presenting here, like I have to present slides. I thought this was more like a fireside. But luckily, I have one slide one thing I wanted to, kind of discuss specifically. And I think you guys are already, many of you guys who are active in the Web3 space, is like the aggregation. Basically, I think Nick also talked about it, and then Michael also talked about it a little bit. We believe so basically, this whole blockchain scalability, industry, I would say, originally we all started with these monolithic blockchains, like Bitcoin is a monolithic blockchain. That means you have one single state machine, Ethereum, Solana, all of these are, and many kind of L1s, I think most of the L1s, few of them tried sharded, which are basically sharded state machines. When I say state machine, I mean a blockchain is nothing but a state machine. It's a ledger, right? And that ledger stores who holds how many tokens, how many eigenlayer points, and things like that. And points basically, which looks like the biggest innovation of our industry currently. And airdrops, of course. So who holds what? That's the ledger, stores today. And that's the state machine. And these monolithic state machines, they are very good. We have the composability across these smart contracts. On the top of the state machine, you write these smart contracts, and then those smart contracts interact with each other. And that has always been touted as the most use case, or the biggest value of blockchains, that you can have composability between different smart contracts, which are applications. But the problem is that if you have single state machine, no matter how much optimizations you do, at the end you are hitting the same database, right? So, for example, Solana has done a lot of good work over there, and there are multiple other, like Monad is doing with EVMs, and there are multiple other blockchains who have tried to optimize the performance on one single, I would say one single state machine. Problem is that no matter how much you scale, no matter how highly performant you make it, there is always the limits of physics starts approaching over there, right? For example, some of these blockchains have 10,000 TPS. With some more optimizations, you could probably go to 20,000 TPS. But then you are doing parallelization, which wherever there is a concurrency, those transactions are failing and all that. So it stops, beyond a certain point, you cannot scale those monolithic blockchains. And then, then came the modularity, the modular blockchains approach, wherein everybody can launch their own blockchains. People can have different app chains, and people have sovereignty on what they want to choose, what kind of VMs, what kind of decentralization profiles and all that. But the problem is it leads to fragmentation. I think many of you guys who use blockchain extensively, you'd have seen you have to bridge from this chain to that chain, and it's a mess, right? And the end game of blockchain is where these blockchains start feeling like internet. When you join internet today, you go to booking.com and you look for your flight, and then you go to the payment page, and then on the payment page there is some payment kind of engine, and that engine basically you use to make the payment using your credit card. And it's not like you have to bridge your funds from one chain to another. Your credit card has your funds, and then you can pay it on any particular website wherever you want to pay. And this is not true for blockchains as of yet. And the aggregation thesis is actually talks about that. This modularity kind of takes the blockchain scalability to kind of internet level scalability. You can have hundreds and hundreds of, or thousands of blockchains, in fact millions of blockchains. And I expect, and I will argue why I feel so, that there will be 1 million blockchains in next 5 to 10 years, app chains to be precise. But they will all be interwoven together. Just like on internet we have TCP/IP, similarly on blockchains we will have one single, because this is basically about trust. So we'll have single layer of trust, and as of now it's pretty much clear in the research circles is that single layer of security and safety is zero knowledge technology. And that's what enables aggregation. And I'll talk more about that. But before that, this is one part that we have not done a very good job at. When people think about Polygon, what is Polygon? There is Polygon POS chain, which has this massive number of users. I think in the last 2-3 days, 1.1 million daily active addresses. Even with Solana having 1/10 of that fees, I think Solana has 650K addresses daily active. So there's huge number of retail using over there. If you go to the DEX screener, you see the number of small trades that are happening on Polygon PS are a lot. And then there is Polygon ZK EVM. The ZK enthusiast here will know that there is Polygon Maiden project is there, which is basically building, a VM which allows privacy, on the client side for the users, and so many other things even Avail, the data availability solution that you see today. It was incubated inside of Polygon. Then we spun it off because we believe in Ethereum and Ethereum's data availability more. So many things have been there that we have not done this good job of explaining Polygon. And to me, Polygon, what we are trying to do Polygon, and we don't care if there's a short-term value accrual and token and these things. What we are trying, and what I started into this ecosystem and I got into the scaling side, I wanted Polygon to be a part of this new infinitely scalable, internet scale network. So that's the basic requirement for us. Whatever architecture we are working, it took us 2 years to reach there. But the architecture now we have, if you talk around research circles, they will tell you this is the only architecture which can actually scale to million blockchains. I'm actually saying very openly, the aggregation architecture Polygon is now, we launched the V1 of this. It can actually literally scale to 1 million blockchains. And that's our core goal. We want to build a planetary scale, internet scale, Web3 network, blockchain network, which can have millions of these blockchains. But for the end user, just like it feels on internet, it will feel like you are on one single chain. You have one single balance and it can move around. And that's what aggregation enables. So, very briefly, I think people, who have not been following, let's say, until 2023, early part of 2023, there were primarily these, monolithic blockchains, single state machine, all the transactions happening in one place. UX good in terms of the composable smart contracts. But, again, scaling limits, you cannot scale Polygon POS, you cannot go beyond, let's say, 200-300 TPS and all that. At the peak of these inscriptions, went to 20 million. And I think many of us, you would have seen, then when this inscriptions, tsunami came, I think Polygon POS was the only chain which was able to take 18 to 20 million transactions per day. And I think Avalanche went down, the fees, on Polygon, the peak fees went to 10 cents. On Avalanche, I think the peak fees was on the C chain was $400. Ethereum, the fees went to $600-700. And Arbitrum one went down. There's so many blockchains that went down because you have the scalability limits. And I don't know, even it was very good that Polygon POS really cranked it hard, but who knows, any of these monolithic blockchains could have faced congestion at least, if not downtimes. So then in 2024 and I think later part of 23 also, you have seen this OP stack, Polygon CDK, now Arbitrum Orbit. These kind of stacks have come up and people are launching these app chains. And now we are becoming this completely fragmented area where people have to bridge all the time. And then when you're bridging from one chain to another, you have to rely on 3 securities, chain security of chain 1, security of the bridge, and security of the chain 2. And we have all seen that probably more than $1 or $2 billion have been lost just because bridge gets hacked in the middle, right? So having a single security zone is what zero knowledge technology can enable. And this is what we say, that the evolution of scaling, from monolithic to modular, especially building on top of what modular kind of architecture systems provide with DAs and execution environments. Aggregation can make all of these blockchains feel like one single blockchain, and also have all of these blockchains in one single security zone. And how does it work actually? So essentially you see that these we have mentioned 4 or 5 chains, but this could be, there are already some L1 blockchains are joining in. There could be thousands and thousands of these chains. And all of them have their ZK proofs. And on the ZK proofs, like we have really improved the performance of the ZK proofs. And today they are like totally feasible. And the per transaction costs are like 0.000402 actually on some of the Polygon provers. And so you can have all of these chains. All of them are basically submitting their proof to this aggregation layer. An aggregation layer combines all of the proofs into one single proof, and you are into a unified bridge contract. When you have that, then what you can do is you have a transaction. Let's say you have a gaming chain. Let's say CDK chain 1 in this diagram. You have a gaming chain, and you are playing a game there, and you earn $5,000 worth of gaming tokens there. And now you want to convert that into USDT, but the markets are available on Polygon ZK EVM, or let's say Arbitrum, like if assuming they are connected, or any chain which is connected, let's say Near blockchain, which is going to connect into the ZAG layer, and other L1s also. So you can actually initiate a swap transaction there on your app screen. And for you simply click a button. That app actually does your let's say deposit transaction, and then submits the proof, ZK proof, to the AG layer. And the AG layer, the chain 2 where you are actually swapping, let's say Polygon ZK EVM, quickly sees your proof, and it sees that this transaction, which is an incoming transaction from some other chain, is actually a part of this ZK proof of chain number 1. So it can trustlessly accept it. There's no crypto-economic security there. There's no OP, optimistic, kind of this thing over there and all that. Although those things can be applied on top of it for, I'll come to that, like for even faster atomic transactions. But point being, this is the security, like mathematical security you are offering. There's no crypto-economic security required when the ZK proofs are coming in. So basically you do this transaction, it goes to chain 2. Chain 2 sees that this is a part of the proof, swaps, and deposits your USD back to this chain. And now when the chain 2 submits the proof, the chain 1 sees that, okay, there's an incoming transaction, but there is a proof, and this transaction is a part of that proof, and then your money is back onto you. So as a user, you click and you see like step 1, step 2, step 3 in like probably 10-15 seconds, and then you have your money back on your chain. Like OKX chain, for example, is a very big example over there, which will have like, let's say, huge amount of liquidity, and you have an app chain, which is, let's say, a social chain or gaming chain, whatever, and people are, playing and earning value, and they can exchange that value directly onto the OKX chain without, having to think about bridging and all that. It all happens in the background. Like some of the technical folks here, you'll say, okay, even if there is a proof, there is some level of bridging happening here, right? So who provides the liquidity on the other side and all that? But the fun part is, because this is aggregated ZK proofs, you will have single representations of those smart contracts. Let's say USDC will have the same like interconnected smart contracts across the chains. So when you actually are moving your USDT from one chain to another, you're simply burning that token here and then minting the USDT on the other side, trustlessly, mathematically, because it's a part of the ZK proof. So all of these tokens are basically not like right now when we say, oh, this chain has native USDT, this chain has native USDC, or this token is native on this chain. After this architecture is like, fully, kind of blossomed, every token is native to all the blockchains, like across this platform. And that's when it starts feeling to you like this entire network, doesn't matter which blockchain you are on, if that blockchain is connected with the ZK proofs, with this AG layer or some structure like this, you feel like you are on the same chain. The experience is like you are on the same chain. And that's the end game for us, where we call infinite scalability. As many chains people can launch, like thousands, and at that full blossoming, it will support like millions of chains in like, let's say, in like 1, 2, 3 years of roadmap. But even now, by the end of this year, it will probably support 1,000 chains or something like that. And it will go exponentially from there. And then those chains have that. That's why we call it like AG layer is unified, infinite scalability and unified liquidity, is because, as I said, that all these tokens are essentially become native to all the chains. So for example, I'll give you one more concrete example also. Like let's say you are a small app chain, you launch with the CDK layer, and then OKX chain is connected to the OKX chain already will have, let's say, withdrawals from the OKX network, or Polygon ZK EVM, let's say, is connected to Binance. And now you want your users to bridge money to your chain directly from Binance. Today, it's super hard because you have to get your chain integrated into Binance or OKX, and they have a pipeline of 50, 100 blockchains, and it's like they have to do it very securely, so they have to take time on all of the things. There is no way to do it easily. But when you are connected to the ag layer, if one chain is connected to an exchange, all the chains are connected to that exchange for the withdrawals. Because on OKX, what I will go is, I'll just select, let's say, ag layer, and then it will show me which chain you want to transact on the ag layer, and then you can select your chain. And this is what we call bridge and call function. So it will simply send it to the ag layer, and ag layer will know that, okay, this is this chain identity, and then drop the money on your address, withdrawal address on that chain where you are expecting it. So the kind of network effects it starts bringing in is like next level after this. And also on Ethereum, you have a unified bridge. So on that unified bridge, you have billions of dollars of liquidity, and none of that liquidity, if you want to move from chain 1 to chain 2, you don't need to go to Ethereum, because all those ZK proofs are actually constantly updating the global state root on Ethereum. So you can move the funds from one chain to another without going to Ethereum, as far as the proof has been submitted by your chain, which is like depends on which chain you are and how frequently that chain is submitting the proof to Ethereum. And the way ZK scaling is, being optimized, we feel that, it will go to like probably 5 to 10 seconds for each of the chain. And then what is happening is, as I said, unlimited scalability. On top of this, let me go back. Back doesn't work. So on the chains, okay, it went. Okay, on this chain, then you can have on top of this shared sequencing, where the shared sequencing ecosystems are running the nodes, and we call this, let's say, clusters, or like, these groups of chains which want to interact with each other at extremely fast rates, because ZK proof is still going to take 10 seconds. Like you do a transaction, 10 seconds, the proof goes, and then other chain picks it up, and then they prove 10 seconds, and then it comes back to you. So it takes like 20 seconds, which is still like Ethereum's block confirmation. It doesn't, like when you go to a payment page on any other website you use, the payment page generally, when it's loading, it takes like, 5 to 10 seconds or 15 seconds. It's not that bad. But if you want instant atomic transactions, so for example, I am on ZK EVM, I want to take a flash loan on OKX chain, and then, use that flash loan to take a leverage position on, let's say, some lending borrowing. I take the flash loan from lending borrowing chain and do some arbitrage on some DEX. Whatever money I get back, I want to deposit back into the lending borrowing pool and get the profit back to my chain. You'd be able to do it in one single atomic transaction using shared sequencing, because in the shared sequencing, these shared sequencers are running the nodes for all the chains. And the chains who want to collaborate within this shared sequencing environment, they can actually give the special sequencing rights to them, or basically like Espresso, for example, which is a prominent company in the space, they call it like a sequencer marketplace, right? So somebody can buy the rights of sequencing on your chain from this ecosystem if you are connected to this marketplace. And then what happens is that this block proposer proposes blocks on both of the chains. So this block says, deposit the transaction onto other chain, and the other block on the other chain says, take a flash loan, sell some arbitrage into the DEX, get the other tokens, pay back the loan, and deposit into this. So this atomic transaction in like milliseconds can happen to you. You can experience if there are chains which are participating in one common cluster. And it happens in Web2 world all the time. Like you have multiple banks which come into consortiums, and between those banks, if you are transferring things, these are much faster. And this is also going to happen in the Web3 space. And then you start feeling like when that kind of experience materializes, then you see, and this is where I will end my, I'll submit my case, is that when you have that level of composability across the chains, then by first principles, any application, whether it's a DEX or loan or game or anything, they would always choose to have their own chain. They will never be on a shared chain, like which is the integrated thesis, like let's say Solana side and all that all the applications should be on one single state machine, one single blockchain, so that they can compose with each other. If that composability is available across chains and you have same zone of security, my argument is all the applications will always want to choose their own app chains. Why? Because this is how Web 2 works today. When you are launching a mobile app, you don't go to some other big mobile app and say that, or Google or Gmail's mobile servers and say, can I host my app on your servers? This is exactly like this. When people are launching their app chains on shared blockchains, they are essentially saying that, okay, this is a public server, let me deploy my application here. And this used to happen when the Web 3 or Web 2 world was very, kind of new in 2001, 2, 3, when we were actually, like I was also starting as an engineer, and we used to deploy our applications to these shared servers all the time. And then some application on the one particular day will have heavy load, and then your website is down. And this is exactly what happens today. If you have a Bored Apes Mint suddenly on your chain, and you are a gaming application, and you are paying for the user's gas for better user experience, suddenly your gas fees is short by 5x. And on that day, your gas fees expense, which is $100, now it is like $500, $1,000 a day, and it can continue for a few days. Which application which wants to offer good user experience to their end users, which application would want to go through something like this? If you have an option where you can have a dedicated high service level blockchain for yourself, which is, let's say, single sequencer, so your experience is also 200, 250 millisecond, and you have dedicated capacity, and then your application can compose with any other blockchain on the other side, right? So then, like that's the argument about, and I'll finish over here, is that if that kind of composability is solved, which we are seeing that it's not even a research problem, it's an engineering problem, it's coming. When you have that, my submission is that no high-scaled application would ever want to exist on a shared blockchain, whether it's public or private. They will choose their own app chains. And the app chain world is coming. Aggregation layer is what brings it all together. Thank you, everyone.